Oh man, we got crazy microphone fuzz today. Greetings and welcome to another Evil Dojo presents raylib game development. I'm trying to get rotations working properly, and that led me to create this little quick demo here. So let's go ahead and build this thing. As you can see, we've got a very simple setup here. Alright, that's a little bit better for your visualization. Can I make it full screen for you? There we go. So, why was this difficult? What problems was I encountering? Why did I have to make this demo? So let me see if I can go about fixing a few things here real fast. So one way that we're able to do a lower level drawing of the texture is by specifying using the RL functions such as textchord2f and vertex2f in order to specify the box where the texture actually gets drawn. Everything draws correctly, kind of, at the moment. I'm going to have to redo flipping and stuff, but there's also some issues with the hitbox and the collision that originally weren't an issue, but as I began working on catching the knives, because as you can see, we have knife catches, when I fire the knife after catching it, we want it to rotate. And doing this is not as straightforward as it would like it to be. So we're taking some of the lessons that we have discovered doing this the other way, right? So here's the little demo file, and here's sprite.cpp for the game, right? So if I were to like go in and take out a lot of this stuff, or rather, yeah, for a moment, let's take a look at how it used to look. So we're going to put in the original draw code, which is simply this. So we've got some weirdness with the rotation, right, at the moment, because I'm attempting to rotate but for some reason, and while we're rotating, the origin gets offset, and attempting to like manually adjust the origin is resulting in some weirdness, right? Like we redefine the origin here, and so by default it's at 0, 0. But when we shift it, it's naturally moving you know, to the it's moving up a little bit and to the left. But if we comment this out and we attempt to just do things around the origin, the rotation is super weird. So it looks like it is spinning around 0, 0, but it's spinning at an unexpected location. It's spinning like around 0, 0 as opposed to around the center. And while I'm able to get it to rotate around the center by adjusting the origin, this shifts the entire position of where the sprite is. This, you know, is why I'm drawing so many bounding boxes right now in order to figure out the fucking geometry of this motherfucker. And that's when I realized, oh shit, there's probably some extra shit that I'm gonna have to do. And digging around, this is where I discovered the RL functions. So digging around in rlGL.h, you discover certain functions like rlMatrix. Actually, let's do rlPushMatrix. So it's also like rlRotatef. Like, here's the implementation for that function. And I came to a lot of this from a post like over here, where they'd be like, how do you rotate a shape around its origin? And Rayson himself says rlRotate and rlTranslate before draw a rectangle. And so I'm assuming that we're going to be able to get this to work with textures as well, because there's certain examples in the example folder. For instance, right there, where they're rotating a cat inside of a complex polygon that they've defined. So this should be a pretty straightforward one-to-one. Like, the only reason that I created my own little demo is that this is way more simple and closer to my use case than the polygon is, but same idea applies. So let's step through and understand what it is that we're doing, why we need to do it, and how this solves my problem. Alright, first let's comment out these lines right here and understand what the default without doing these transformations is like. Oh wait, wrong game, whoops. So actually this is post build on that, so let's do that. Oops. Alright, so the default here, we're drawing a 100 by 100 rectangle up in the top left of our program screen, window, whatever. So first thing that we do is we push matrix. And the last thing we do before we end drawing for this object is pop matrix. So whenever we're working with just a specific item such as the rectangle itself and not hello world text, we can do it this way. So let's make no change, but this is to be expected. So the first thing we're going to do is we're going to translate the position. We're translating it to VX0, which is FCX. And actually, we could just replace that with CX. So that represents the center of the screen. CY, center of screen, 0, which is the Z-axis, and we don't have a Z-axis that we're working with, so keep saying nothing to be done for all. Alright, so now you can see that the rectangle is in, I believe that's the fourth quadrant, or at least it appears that way. But what we've done is we've made 0, 0 now effectively the center of the screen when we're drawing this triangle, or rectangle. So, let's see. We can even adjust it a second time. So now it's in the dead center of the screen. Now, if we didn't translate it a second time, and we decided we wanted to actually perform a rotation, it's rotating, but it's rotating around the top left point, which is effectively 0, 0. If we weren't doing it around 0, 0, we wouldn't have done the translation. Or rather, because remember, with this initial translation, it moves it from the top left corner of the screen to the top left of the fourth quadrant, right? Since that's the center. So where am I going with this? Oops. without this initial translation step, what does the rotation look like? As you can see, it's still rotating around the top left point of the rectangle. Now it's rotating around the top left of the center, sorry, of the window itself as well. There it comes back around again. So we have to do the initial translation to get it anchored on the center of the screen. And then we begin rotating. But while it's rotating, we perform another translation. And this enables us to move the rotated object to yet another point. So if we rotated with like an angle of 0, there's no change to the square or the rectangle. And then when we adjust it to be in the center of the screen now by providing an offset that is equal to half of the size of the rectangle, this gets us directly in the center of the screen. And so effectively we can move it wherever on screen that we want to at this point. We'll do a little test of this by wiring up some keyboard controls to show that we can actually move this rotating object around. And then later on, after my Facebook interview probably, I will implement this directly into Skull's game code. So again, to show that we are now rotating around the center, which is a huge plus, huge upgrade, right? So now we should be able to move wherever the hell that we want to go. One thing that we can do to do this is set up an x value of -50, a y value of -50, and use these as variables to our call to translate. So if we wanted to say the width of the rectangle is always going to be 100, always going to be 100 there, and down here we specify the width and the height, and it's all drawn as if it's being drawn at 0, 0 still. But the second translates. So let's examine this for a moment. What were to happen if I were to pass in coordinates to the call to draw rectangle and didn't do the second translate? It still works. It still does what we want it to. So effectively, I should be able to just manipulate the XY variables and move this thing around on the screen. So okay, so now that's interesting. So I'm pressing left, okay? And it's moving in a very weird way. So perhaps XY shouldn't go there. But instead, let's plug the callback to translate in as if we're able to manipulate it this way. And same problem. The further out it goes, the worse the problem is. So that's an interesting observation to see, and it definitely complicates things thinking about how we can get the object to just move left As you can see, it's now rotating around the bottom of the rectangle, or one of the sides anyway. Now what we want is effectively to have this kind of rotation, but be able to move anywhere on the screen that we want to go. So the initial translate took us to the center of the screen, but what we want is really the center of the square, right? So if the square is going to be initially drawn at 0, 0 and it's 100 by 100, then really this should be 50, 50. If we don't have the second translate, this is what that looks like. So it's actually rotating around 50, 50. And if we were to go back, now it appears like it's rotating around that point. So when we go to draw the initial object and we anchor it at a particular location like 0, 0, when we go to translate, like for instance 50 is half of the width, the height is half of that, and then we have negatives for this. Oops, that's behind. So this still doesn't really allow us to move the see, same problem. So if we're trying to move it, its actual location is going places. So it's going to take a little finagling to figure out fully. Aha, got it. So actually what we need to do is translate to XY on the initial call. So if we set up if we say that we want the rectangle to render in the center of the screen, and we set X equals center, Y equals center, and we initially translate to that location. Then we call rotate on our angle, and then we translate back to 0, 0, which resets everything. And then we go ahead and we draw relative to the offset. So what would happen if we made this 0, 0 again? So it's still rotating, but it's rotating around that point again. So the whole reason that we need that offset which is half of the width half of the height as negatives. That gets it in the center of the screen, and we can now move it across whatever directions and axes that we want, and it's correctly rendering in the way that I expect. So in the next part of this, I'm going to apply the same concept to skull and sprite class so that we can get this kind of nice rotation happening with the knives. I want to see it go faster before I stop. How fast? That's pretty good. Oh wow, that's pretty good. Oh wow. We're getting some crazy stuff here. Alright, well I think that gets the point across. So what we did, again, is first we translate to the desired position of the center of the object. Then we rotate on the angle, and then we translate back to the origin. And then when we draw our object, we have to draw it with a relative offset. In this case, the offset is 1/2 of the width and 1/2 of the height as negatives to whatever object it is that you're drawing. And then we pop our matrix. And that should be sufficient for what we're going to be doing over in Sprite. Here's our draw method again. We're gonna finagle stuff over here, over there. It's gonna take a little bit, but I'm gonna figure it out. The one thing I'm gonna do first is whenever we're actually initializing we're going to default is spinning to true. Oh, they're moving fast. That's not how fast I wanted them to spin. But remember that at the moment, the way that we're handling the spin is through rotation angle. And we have this origin that gets set whenever it is spinning, so there's a bit of a weird offset, and then we also have a rotation angle equal to the velocity, but I think velocity was initially not initialized, which is why I was freaking out. And you notice everything's a little bit off from where it should be at, but everything is rotating. It's just not as expected. So we're going to play around and fix that. Alright, so no rotation, right? Alright, so remember, we first push the matrix. Then we translate to the XY position that we want, the center of the object to be at. And then we rotate by the rotation angle. And then I think we should really translate back to the origin, right? Because that's what we do over here. And then when we draw it, we need to draw it such that the destination is updated correctly. So if we're using the destination and we don't have to actually move it, this should be okay. Oh no, where'd it go? Damn it. I was hoping that was going to work. Copilot was trying to do something different for rlTranslate. Okay, I think we got it. Yeah, we got it. Oh shit, yeah. What's up? What's up, everybody? Oh man, yes. Okay. So we've effectively got what we want working or looking the way that we want. Now all I have to do is go back and adjust the squares and the boxes, make sure that everything syncs up nicely. And as an example of this, we can go ahead and take this over to our draw hitbox over here. And it should correctly update all of the squares. So that's pretty good. So this can be very useful for debugging and also gives me some ideas for some Geometry Wars style games to make in the future. That's everything I wanted to show y'all today. I'm gonna load this up, clean it up, get it up to y'all. And until next time, y'all take it easy. Evil Dojo out.